Hi everyone, so today we're going to be talking about greenhouse gases. Okay, most likely a particular one called nitrous oxide. But for those that don't know what greenhouse gas is, I'll give you a quick overview of what to expect within this video. Okay, so to start off, energy from the sun drives the Earth's weather and climate. The Earth absorbs some of the energy it receives from the sun and radiates the rest back towards space. However, certain gases in the atmosphere, called greenhouse gases, absorb some of the energy radiated from the Earth and trap it in the atmosphere. These gases essentially act as a blanket, okay, making the Earth's surface warmer than it otherwise should be. Alright, while this greenhouse effect occurs naturally, making life as we know it possible. Human activities in the past century have substantially increased the amount of greenhouse gases in the atmosphere, causing the atmosphere to trap more heat and leading to changes in the Earth's climate. Here is a short diagram of what or how the greenhouse effect works. Today we'll be talking about nitrous oxide. Well, for those of you who don't know what nitrous oxide is, it's N2O. Alright? This accounts for about 6% of all US greenhouse gas emissions, and that's only from human activities. Nitrous oxide is naturally present in the atmosphere as part of the Earth's nitrogen cycle, and has a variety of natural sources. However, human activities such as agriculture, fossil fuel burning, wastewater management, and industrial processes are increasing the amount of N2O in the atmosphere. Nitrous oxide molecules stay in the atmosphere for an average of 120 years. That's a lot of years. And the impact of 1 pound of N2O on warming the atmosphere is over 300 times that of 1 molecule or pound of carbon dioxide. For those of you who might be thinking this, or this, but in reality we're actually talking about this molecule. Alright everybody, so we're going to be talking about how nitrous oxide is emitted into our atmosphere. The first one is agriculture. Alright, nitrous oxide is emitted when people add nitrogen to the soil through the use of synthetic fertilizers. Agricultural soil management is the largest source of N2O emissions in the United States, accounting for about 75% of total US N2O emissions in 2012. Nitrous oxide is also emitted during the breakdown of nitrogen in livestock manure and urine, which contributed to about 4% of N2O emissions in 2012 alone. So the second type of emission is through transportation. Nitrous oxide is emitted when transportation fuels are burned. Motor vehicles, including passenger cars and trucks, are the primary source of N2O. The amount of N2O emitted from transportation depends on the type of fuel and vehicle technology, maintenance, and operating practices. Okay, and the third type of emission is through industry. Nitrous oxide is generated as a byproduct during the production of nitric acid, which is used to make synthetic commercialized fertilizer, and in the production of adipic acid, which is used to make fibers like nylon and other synthetic products. Now that we've discussed the 3 types of nitrous oxide emission, let's see if we can find ways on how to reduce this emission. One of the first things that we can do is manage our agricultural emission source. The application of fertilizers accounts for the majority of N2O emissions. Emissions can be reduced by reducing nitrogen-based fertilizer applications and applying fertilizers more efficiently, as well as following better manure management practices. A secondary type of nitrous oxide reduction would be for transportation. Nitrous oxide is a byproduct of fuel combustion, so reducing mobile fuel consumption in motor vehicles can reduce transportation emissions. Additionally, the introduction of pollution control technologies, such as catalytic converters, to reduce exhaust pollutants from passenger cars can also reduce emissions of N2O. Last but not least, the third type of emissions reduction could be for industry. Nitrous oxide is generally emitted from industry through fossil fuel combustion, so technological upgrades and fuel switching are effective ways to reduce industry emissions of N2O. Productions of adipic acid result in N2O emissions that can be reduced through technological upgrades. Finally, I just wanted to show you guys a graph of what exactly is going on with our emissions with nitrous oxide. The following will provide a graph that will allow you guys to conceptualize at least what's going on with all the emissions of nitrous oxide in our atmosphere. Last but not least, we must all play our part in trying to reduce greenhouse gas emissions. Regardless if it's CO2, methane, or nitrous oxide, all of these gases play a vital role in heating up our atmosphere and making things harder for everybody around us. You can take our current temperature as an example. It's getting especially hot. Now we don't want that in the future, do we? Alright, thanks for watching.